Okay, so as part of today's class, this is the agenda that I have already shared. Okay, we are going to discuss about introduction to distributed system. Then we'll see about the introduction to GFS and MR. We'll see what is GFS and what is MR. Then introduction to Hadoop, evolution of Hadoop. Then we'll talk about one of the important feature that is yarn, one of the important component of Hadoop ecosystem that is yarn. Then we'll talk about task processing in Hadoop. Then we'll move to different tools for Hadoop that we are using as part of the Hadoop data processing and all. Okay, so just let me give a quick recap. So far we have already completed in the last class. I mean, before the last class, we have already completed the different big data industry case study, and before that we have already started with the ecosystem of the big data. What is big data? Big data characteristics and its real time application. What are the five V's they have introduced? Then at latter point of time, how scientists they have reduced from 5V to 4V's of big data. Okay. Then we have also seen the big data major sources. Then what are the different types of data? That is structured data, unstructured data, semi-structured data. We have also seen different kind of data. Then challenges of traditional database or system. We have also seen. Then how to overcome the issue that's faced that we are facing in the traditional system. Then we have seen as part of the solution, scientists they have given a beautiful ecosystem that is called Hadoop to deal with big data. Okay, so today we'll extensively discuss what is Hadoop, what are the different component of Hadoop, what are the major problem that is getting solved by the Hadoop and all. Everything we'll discuss, right? And we have already seen this thing as part of previous class. Okay, if you have not attended, then you can go through the recording session. Okay. Then, as in the previous class, we have already completed the big data industry case studies. So, as part of that class, we have completed two different case studies. One is Walmart case study, which is related to retail domain. Another one is eBay case study, which is related to e-commerce domain. Okay. Similarly, we have also seen like kind of Amazon.in or Flipkart.com. Okay, online shopping website. So we have already seen extensively. We have discussed how supply chain management work. Okay, how Walmart uses big data, how Walmart is tracking its customer, how Walmart is making a real difference to increase the sale. Then how big data is used for analytics purpose as an analytics solution as Walmart. We have seen different type of social media solution, mobile big data analysis solution, then big data in the retail industry also we have seen, right? So all the things we have already discussed extensively as part of our previous classes. Fine. Now let's come to our today's agenda. So today we are going to see these are the agenda I have set. Let's start with the first one. We'll deep dive into each and every subtopic one by one. Okay. Let me write down the first one, that is introduction to distributed system. Fine. Guys, what do you mean by distributed system? Anybody having any idea? Please let me know. You can pin on the chart. What do you mean by distributed system? Simply in the English terminology, then we'll try to understand on the technical point of view. So seems like distributed. What do you mean distributed? For example, I'll tell, let's say certain data point. Okay, it's just present like this, confined into a single unit. So this is not distributed, right? This is like in one place, single place is present, confined into a location. So within this circle only, all the data point are present, right? But if I tell, let's say I'm just drawing my 2D axis, let's say this is my x axis and this is my y axis. Even if same things also I can draw here. This is my x-axis. This is my y-axis. Fine. Here, what happens? Let me use a different color. If my data points are present like this in the 2D axis, then can I say my data point is present in a scattered manner, or I can say distributed manner? Can I say like this? Yes or no? Can I say this or not? So the first example is nothing but isolated. This is distributed. So this is present in a confined area, in a particular area, I can say. Isolated or particular area. Distributed means just in a scattered manner. I can say scattered. Present in a scattered manner. Okay. In the layman terminology, you understand what you mean by distributed. Similarly, whenever I'm telling distributed system, what do you mean by that? Let's try to understand. What do you mean by system? System is nothing but think about any physical, desktop or laptop or computer. Basically, we call it a system. Okay, let me draw that. Try to understand. These are the basic and I can say fundamental. If you understand this, then going forward it will be easy for you to understand each and other concept. So this is a system, right? For example, let me draw other system as well. This is also one more system. Second system, third system. Obviously, a lot of systems are there. Okay, so I'm just putting dotted line. So let me put a just last system. So don't think there are only four systems. Dotted means lot of systems are there. Okay. So these are called system, each and everything. Like I can say system, right? So suppose I can write system one. So let me write on different color. Yeah, that's the system one. Can I write here? Okay, system one, system two, system three, system four, and the total let's say system n. Okay, system n. If these systems are interconnected with each other, means they're communicating with each other. How they will communicate? So obviously, there will be a two-way communication. A request is going from system 2 to system 1. Then again, response is coming back from system 2 to system 1 to system 2. Okay, two-way communication. So request, then the response. One is let's say going, another one is coming. Similarly, request, response. Okay. For example, this is request going, response coming. Similarly, this one. So guys, what happens? You can see one central computer is there or system is there which is interacting with a different system, and there is no communication between this system. There may or may not, but that is not important for me. For me, what is important? One central system is there which is controlling all other systems. That means this is the typical architecture of a distributed system. If I draw distributed system, so I can say typical architecture or typical diagram. Let me write down. Of a distributed system. Guys, I'm going from the basic, try to understand these are the fundamental things. You may get lot of question in the semester exam or maybe in the interview as well. Okay, try to understand. Then we'll deep dive into more complex part. typical diagram of a distributed system. That means you understand one system which is kind of master node or master system which is controlling all other system. The center system which is controlling all other system, that is called master node, or I can say name node. Name node. And other system which is controlled by the master node, that is called data node. Data node. Also the in short I'm writing dn. So if I tell, let's say, data node 1, so it will be data node 2, then this will be data node 3, and dot, 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 then this will be data node n. Clear, guys? Data node n. Okay, data node n. So always in the distributed system there will be one master node, I can say one. So master node, or some people call it as name node, all are the same, just different name. Always it will be one. Coming to data node, it will be always, I mean, more than one. More than one. Obviously, I mean, it will 2, 3, 4, whatever. Based upon your configuration, you have to do it. Okay. In addition to master node and data node, there is another node also present, that is called secondary name node. Secondary name node. We'll see each and everything, each and every component I will explain in depth going forward in the upcoming classes. Don't worry about that. Okay. Today is the first class. I'm just building the foundation, building the enthusiasm, and I'm trying to make you comfortable with all this terminology, so that going forward, whenever I'll use, okay, I want to talk with name node, or maybe my name node, or memory is this much, my data node memory is this much. You should not sort by listening this word. Oh, what is name node? What is data node? What is secondary name node? What is worker node? You should not worry about that. Okay, that's why be comfortable with all this terminology in today's class. Fine. So now, so I can say, let me give some naming better. So for example, this is the my first master node, then data node, then secondary name node. Okay, guys. Sometimes people call this data node as worker node. These are the different naming conventions. I can say synonyms. Okay. So sometimes people call it as, let me use the same color. Yeah, worker node. Worker node. So whenever I'm telling worker node, it's not confused. It means I'm telling data node. Whenever I'm telling master node, you should not worry, you should not confuse. That means I'm talking about the name node only. So name node, master node, all are the same. Data node, worker node, all are the same. And secondary name node is obviously a standby name node. That I will discuss. Nothing to worry. Why secondary name node? What is the work of data node? Why we need data node? Why we need name node? Everything we'll see in depth in the upcoming classes. Nothing to worry. Fine, guys. Till this point, any doubt? Any doubt so far till this point? Please let me know. Please let me know any doubt so far. Okay, now let's move. Okay, so I'm just talking about the introduction to distributed system. So typically, distributed system looks like this. It's nothing but a combination of, if I write the note or conclusion in one line, it's nothing but distributed system is nothing but a kind of master slave architecture. Okay, so what is slave? Another new naming convention you have used. This data node is nothing but also slave node. SLAD, slave node. That's why I told you today class is just you have to acquainted all the naming convention. So something like that. Think about. So master node, this is called slave node. This is called name node, this is called data node or worker node. Then we have something called second line name node. So a distributed system is nothing but a master slave architecture. Okay, it's nothing but I can say a distributed system. Okay. Clear guys. Any doubt so far? Any doubt so far? Okay, fine. Now, first one we have successfully completed. Now let's talk about the introduction to GFS and MR. What is the GFS and MR? We'll see. Now coming to the second point. MR. This is just introduction part. Then we'll deep dive into in details in upcoming classes. Guys, whenever Hadoop come into the picture, I mean come into the market, particularly I can say in the year of 2006 officially. Okay, so Hadoop, let's say Hadoop launched. Okay, launched officially in 2006, right? So at that time, first when it was launched or it was introduced to the technology world, GFS stand for nothing. Let me just write down the naming convention or acronym. Then it will be easy for you. GFS stands for Google File System. Okay, Google File System. So, in the year 2006, Google has launched or they have just introduced a white paper, a research paper. We call it as a white paper, right? Or you can say a research paper. About the distributed system. The name is called or distributed file system is non name are called name called GFS, Google File System. So obviously it's a file system. They thought what name will give. Then Google will decide, okay, as we have launched, we have the market leader. Let's tag our company name with that file system. So they just tell Google File System. So instead of calling a lengthy name Google File System, in short they are telling GFS. So GFS means Google File System. Getting my point? So in Hadoop, whenever they are introduced in 2006, first it was introduced the I can say plain vanilla file system is nothing but GFS or Google File System. Obviously, there are lot of disadvantages were there. That was not none of our business. We no need to dig into that because that's a historical kind of things. Okay, lot of whenever any product, let's say any mobile come into the market, initially the first version you may be seen. Okay, that is some front camera issue, back camera issue, maybe some audio related issue, maybe picture clarity is not good, is hitting too much. Okay, battery backup is not good. Then customers start raising the complaint and all. Then going forward, the company try to release the patch. You might have seen software update. They're asking for update. What do you mean by update? They're releasing the patch or fix a software so that once it will be connected with your broadband internet connection, if you click on the update, then it will take some time. The patch will be updated or installed, then it will be restart, then that issue will be removed altogether permanently. So whatever the product we are going for, it may be mobile phone, it may be any LED LCD TV or whatever it may be, right? So initially there will be some problem will be there. Going forward, whenever they will launch the different version. For example, first version is version 1, then version 2, then version 3, or maybe in the 3.0, 3.1, 3.2, 3.3, something like that. So each and every release they try to improvise. And that is same things in case of software as well as in case of any physical product. You see, for example, let's say you have a plan maybe 6 7 years before, you have already purchased a Activa Honda. Okay, at that time 3G was there. Then latter point of time they have improvised something, maybe in the headlight or maybe in the engine capacity or maybe something else. The 4G came, then after 4G 5G came, then in 2000 around after 19 onwards or 20 onwards 6G came. Okay, I don't know whether 7G came or not. Okay, so like this, in the bike, in case of bike product or mobile product, any other product. Similarly, it's happening in case of software also. So initially maybe you are using Python 2.0, then 2.5. So generally we call it a 2.x. Okay, we'll see also what are the different versions of Hadoop and all. Then 3, 3.0, 3.1, 3.2, 3.3, now 3.10, 3.11 also introduced. But anyway, that is not stable version. People are still rely on 3.6 or 3.7, something like that. Even if people are using 3.10 also. So that is happening everywhere. So in case of Hadoop also, this is the same story. Now, there are a lot of loopholes are there, okay, with GFS and all. As part of improvisation, as part of improvisation, another file system come into the picture, that is again file system, come into the picture, that is called as HDFS. Then sir, what is the full form HDFS? Obviously, it's not two different word. So I'm just writing file system plus HDFS. So it's nothing but FS stand for file system. You are clear, right? This is stands for file system. Let me scroll it up a little bit. Yeah. Okay. And HD stands for Hadoop. Hadoop distributed. Hadoop distributed file system. But it was not launched before. I mean, past time. Past time, the file system, whatever launched, it was called as Google File System (GFS). But there are a lot of disadvantages. They figure it out latter point of time. They means scientists. Then, as part of improvisation step, Hadoop distributed file system was launched by generally. I mean, it was given by the a company called Yahoo, YAH Yahoo. Why? Because initially Google File System they have launched, and they have a lot of arrogance. They thought that this is the market leader, but lot of faults and lot of error and lot of disadvantages was there. And whenever they introduce this white paper or research paper, in that I can say seminar itself, there are certain people from Yahoo company they have also attended, and those people are very much smart. So what they have done, obviously they have gone through the research paper, they will try to figure it out, try to build their own file system. And after 2 3 years, whenever they have a launch, they have officially launched another file system, the name called Hadoop distributed file system, which is super intelligent and far better than GFS. Now, from that time, Google never saw that arrogance and proudness in front of any other company going forward. Okay, because they thought that, oh, we are a smart fellow, whatever we develop, nobody can cross. But that is not happening in case of Hadoop. So Yahoo cross Hadoop, Yahoo cross Google in case of file system, Hadoop distributed file system. In the latter point of time, I mean, Google, they have introduced something else. That is a different story altogether. But how it come into the picture, the historical things I'm just talking in front of you. Guys, clear? Now, what is this Hadoop? Okay, you are clear about GFS and all. Now, what is MapReduce? Okay, as we have seen, there is a problem also in the big data, right? So I have already explained in my past class itself, right? Challenging of the traditional system and how to overcome the issue. If you have remember, let me recall one more time. There are a lot of challenges are present with the traditional system. What are those? Obviously, a lot more, but I want to figure it out. 2 to 3 important problem. Okay, problem statement. The first problem statement is with the traditional system. With the traditional system, What do you mean by traditional system? The storage database. It may be anything else. Let's say RDBMS and all. Let me write down also. Okay. For example, any RDBMS, relational database management system. It may be, Oracle. It may be MySQL. It may be SQL Server. It may be DB2. It may be PostgreSQL. The main challenging issue is they have certain limit of the memory or capacity. For example, in the first class itself, I have already introduced how we'll figure it out or tell that is a big data or small data, medium scale data. That is certain range, right? I'm just recalling because it's already a long day back we have gone through. So we have seen if a data volume is more than 1 TB of data, 1 TB of data, more than 1 TB, this is called big data or huge data. Then medium scale data, I can say in between 1 TB, less than 1 TB, and more than 10 GB, I think, right? If I'm not wrong, right? GB. So this is called medium scale data, medium data, medium size data, and less than obviously less than 10 GB, less than or equal to, that is called a small size data. And as you know, all these traditional database, whether Oracle or MySQL, they have the limit. Certain of they can store the data up to max, like 1 TB of data. Max to max of 1 TB of data. 1 TB of data. Yeah. Then what's about whenever my data volume is, let's say, 10 TB or 100 TB? Can I store those huge amount of data inside this traditional database? No. Then at that time, I have to rely on some other storage device. Then the distributed file system come into the picture, and that is why the Hadoop becomes more popular at that time. So the major challenging with the traditional ecosystem is storage, 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 storage limitation, which was overcome by the Hadoop ecosystem. One is storage limitation. Another one is, as we are just storing the data, but what's about the processing part? What's about the processing part? Think about, let's say, in your database, 1 TB data is stored. You want to write a select query based upon certain condition. For example, your select query contents, find out the employee details whose salary is more than 50,000 and less than 2 lakhs. Lot of employee may be there in the 1 TB data. 1 TB data, are you getting my point? Are you able to imagine? It's a huge lot of rows actually. Then it will take a lot of time to SQL query to run on top of that server. Obviously, if you just write select star from that employee table where let's say salary range in between this one, it will take minimum some minute, few minutes to get the result. So that is overcome by the Hadoop ecosystem. So Hadoop ecosystem majorly solve two major problem statements that we are getting in the traditional system. One is called storage, another is called processing. So for example, let me write down here. Obviously, this is the problem we are getting in traditional system, and how it is overcome with the Hadoop, that I'm going to explain here. Okay, so let me write down the Hadoop officially. So Hadoop. Okay, Hadoop solve it. Okay, solution. This is the problem statement. Problems. As part of solution, Hadoop provides a beautiful component to store the data in a distributed manner that is called HDFS. And what is HDFS? Hadoop Distributed File System, which we have already seen sometimes before. Extensively will explain, don't worry. Okay, Hadoop Distributed File System. Similarly, as part of processing, to solve the problem of the processing part, Hadoop has given another beautiful component that is called MR. That is why, as a heading, as a subject line, I have written, okay, introduction to GFS and MR. Then what is MR? It is medicine representative? No, no, no. People may think, because you people are MBA guys, right? So MR, whenever I'm telling MR, people may think it's medicine representative. No, MR stands for map reduce. What is MapReduce and all? Don't worry. There is a dedicated one session on top on map. I will cover that. Nothing to be worried. Okay, just hold your excitement for time being. So MR stands for MapReduce. This is used for processing. This is a processing engine altogether. And what is HDFS? In your I have written, but let me write out here. Hadoop distributed file system. Guys, any doubt so far? Any doubt so far? Please let me know. Any doubt so far? Any doubt so far? Please let me know. Okay. So as part of second point also, we have completed successfully. That is introduction to GFS and MapReduce. And anyhow, introduction to Hadoop also I have completed while explaining, because it's a continuation part, right? I explained what was the problem with the traditional system. These are the two different problems, and how to solve that by using Hadoop. So Hadoop is nothing but, I can say, ecosystem. Hadoop, distributed platform, distributed platform or ecosystem, whatever. Fine, clear. Yeah. Now, evolution of the Hadoop. Anyhow, I have also completed that one. Okay. Now we'll introduce the yarn, which is very important topic altogether. Okay. Fifth. So yeah, YARN. Okay. So before moving into the next topic, let me officially show you some slide whatever I have prepared. So let me see anything I have left or not. Then we'll proceed to yarn. Okay. So let me share my PPT altogether. Written here only.